So I just want to say good afternoon and welcome to our final session of our CPD Accredited Digital Talks. My name is Kelly Easton and I'm the Program Director for the African Construction and Totally Concrete Expo. For more information on our digital content, of course, please visit our website. And I'd like to thank ASPASA for supporting and accrediting this session. In the coming weeks, we will email all those in attendance the validation information. You may then use this to claim through the Engineering Council of South Africa for your CPD. Of course, you will need to be registered with the Engineering Council of South Africa. Your moderator for today is Nico Pienaar, and Nico is the Director of the ASPASA. Nico, thank you so much, and I will leave it to you.
Thanks, Kelly, for being so professional. I must just to start off with thank DMG Events for asking ASPASA to be part of this. Kelly and Zara are two champions. I'm not going to give too much of an introduction for the simple reason that we've got most probably maximum an hour and 15 minutes. So we've got two very good speakers today and very relevant subject matter. We chose them because they are effective. So I think we're going to take questions as we go along. I'm going to monitor the time, so will Kelly, and we will try and answer as many as we can. There is the chat room on the side, which you could use. And I just want to thank all of you for joining. Welcome. This is the way to go. I think we're not going to go another way. We're not going to travel around everywhere anymore. So I think that's the way to go. Our first speaker is, let me just take the paper away, is Jaco du Plessis. He's one of the directors of Go Consult. And Go Consult has been going for many years and they've done exceptionally well. So Jaco is going to cover a very sensitive issue. How does perfectly good concrete fail? I was just before this meeting in a SAFSEC meeting and I asked the question, have we ever had a report about the bridge that fell in the East Rand? And I have been promised for the next SAFSEC Health and Safety meeting that we will get a report back on that. It's so important that we understand these things. We don't have failures like that bridge failure. Jaco, I think I'm going to hand over to you and then you can run with it. And as we go along, we'll try and sort out some questions. Thank you, Jaco, and thanks for everybody else for joining this day. Great.
Thank you, Nico. As you guys know, my name is Jaco. I'm one of the directors of Go Consult. And today I want to talk a little bit, as Nico said, it's a bit of a sensitive subject. It's something that people get quite emotional about. And if somebody tells me that we're going to have to design mixes for a Colto specification, then I immediately start to get heartburn for some reason. It's not just because of all the testing that needs to be done and all the regulations to get the concrete to a certain standard and to get the concrete to perform a certain way. It's just I know that there's always quite a number of issues that come along with projects that run under the Colto specification. And we can talk for hours and even days about this subject, about how some of the rules and the regulations are difficult to adhere to. But at the end of the day, we unfortunately only have about 20 minutes. And what I'm going to try to do is I'm going to give you a scenario of one of our projects that recently ended, which didn't end all that well at the end of the day, but the concrete was placed and it was accepted, but there was quite a number of issues that came through it. And I want to highlight some of these issues to prevent you guys from making the same mistake going forward, especially if you're tendering or quoting for a project to supply concrete to a project like this. We need to remember that the Colto specification, or at least the concrete section of the Colto specification, was originally designed and put together for site batch concrete. When we batch in concrete on site, there's a lot less control over it. The quality control is a lot, it's not as stringent as we would have for ready-mix concrete. And the regulations was originally put together specifically for site batch concrete. Now, when we're supplying concrete from a ready-mix point of view, there are some of the clauses inside COLTO that allows us to work with the SAN specifications, but there's still quite a number of rules that even the ready-mix guys or suppliers needs to adhere to. For this specific presentation that I'm going to do, I'm going to talk about a project we've got, or we had, where a continuously reinforced concrete pavement was involved. So a ready-mix supplier was supplying concrete to a sand-roll project where the COLTO specifications applied, and this was specifically for a concrete pavement that is continuously reinforced. It's got quite a bit of steel top and bottom inside of this concrete road. The concrete that needed to be supplied was a 40 MPa or the W40 concrete that needed to be supplied, and this was then tested by the site laboratory. So the ready-mix guys deliver it. The concrete is sampled by the sand-roll appointed laboratory on site, and the concrete was tested by them. And in this case, the cubes came back, and it failed to reach the specified strength. Now, I am talking about the COLTO specifications, and I do know that the new COTO specifications has been released for review, but that will only be effective end of March next year. So for the purpose of this presentation, I'm going to focus a little bit more on the COLTO specifications, even though it changed quite a bit recently. But the COLTO spec and even the COTO, the new COTO spec, judges the conformance of concrete strength based solely on the cube results. And it does not allow us to drill cores, especially from pavements. We can still get away with drilling cores for structures such as abutments or columns or piers, but for a concrete pavement, there is no allowance in the COLTO specification for us to actually go and drill cores for acceptance, full acceptance or partial acceptance of that. So the payments, therefore, and also the reduced payments, are also determined based on the results that we get from the cubes tested by the site laboratory. And in this case, as soon as the cubes failed, the ready-mix supplier was penalized more than R1 million for concrete that does not meet the required strength based on the results from the test lab. So this was quite a big shock for the guys. And as soon as this happens, we normally go and say, but we want to investigate this to see whether there's something that we can do about it. Now, SARMA and ASPASA many years ago compiled a list of exclusion clauses for COLTO. It was normally published on the SARMA website. And as SARMA is now since closed down, the website is not available anymore, but the exclusion clauses for the ready-mix guys are still available. And we'll have a look at it a little bit later in the presentation. So the site laboratory, in this case, sampled the concrete, made the test specimens on site, and then they tested it. But remember one thing, that a site laboratory is never SANAS accredited. It is not possible for a site establishment to actually get SANAS accreditation. It has to be a fixed laboratory, with one of the main laboratories that can be accredited. The system can be accredited, but the laboratory on site is normally not accredited. And be careful, because in this specific case, the results that came from the site lab had the SANAS logo on it, which was not allowed to be on the reports as the laboratory on site was not actually accredited. The results came in, and we got about 33 to 38 MPa, very consistently in that range. For a 40 MPa specified strength. Now this is, as we know, it's quite low. The project was then stopped until this issue could have been resolved. But the one thing that we need to remember is as soon as we stop the site and we're not actually proceeding with any of the structures being built. There are some standing time that starts to be calculated. I'm sure there's actually physically a guy on site with a stopwatch calculating this. But at the end of the day, every day that this project finishes late, there was a 20,000 Rand a day penalty for late finishing of the project. The laboratory was then visited, and we looked at the crushed cubes when we started investigating them. This is the first thing that I always do. As soon as a cube result comes through and the concrete fails, it doesn't necessarily mean that the concrete on site failed. Because if the concrete fails, it can either be the concrete itself or the test could have failed. And 90% of the time, it is the test. Somewhere during the sampling, the cube making, the curing, the crushing of the cubes, something goes wrong. And if we make a mistake, then we will get a lower result. And I always ask to go and have a look at the laboratory. I want to see the carcasses, the concrete that failed. Remember, concrete is a flippin' intelligent material. Concrete knows when to crack, how to crack. If I can take any piece of concrete or concrete on site, we can have a look at it and it tells a story. It will tell us what was the conditions on the day the concrete was placed in. If there's cracks, it will tell me exactly why it cracked. Because this concrete is intelligent and it knows where to crack. So when I see the carcasses, I immediately can speak to the concrete and it will tell me everything that went on during the testing. And let me show you the cubes that we then saw from the stockpile of the carcasses. Cube number 1. There you can clearly see a horizontal crack on the one side of the cube. The back side of the cube was crushed and this side was completely intact. Cube number 2. There you can see the horizontal crack inside the concrete. Cube number 3. Clear horizontal crack on the one side of the cube. Cube number 4. Horizontal crack, plain on this side, crushed on the back side. And I can go through every single photo and show you that the cubes are shouting out that somebody did something wrong. The horizontal crack is a cry for somebody to take attention, to look at it, to take attention and see that we are making mistakes. All of the cubes tested by the site laboratory looked exactly the same. Incorrect failures. Now, when I get a horizontal crack like that, it physically means that my cube was crushed on the one side and it was pulled apart on the other side, and I had an incorrect failure, and that means that I got a lower result. Guaranteed. I cannot test concrete stronger than what it is worth. I cannot get a 30 MPa concrete, put it in the press, and get 40 MPa results. But I can put a 40 MPa cube inside a press, test it incorrectly, and get a 30 MPa result. That can definitely happen. If I don't put it eccentrically, if my plating at the top is not loose and I put an eccentric load on my cube, I will get a lower result, as we got in this case. I say always, always go and check the crushed cubes. Check the failure patterns. Make sure that you've got one of these stop failures, an acceptable, satisfactory failure. All of these failures at the bottom, where we've got an eccentric load, a horizontal crack, breaking on the one side or on the other side, that is unsatisfactory failures. Unacceptable, which means we got a lower result. But now, what does Colto say in this case? Because now we've got cubes that failed, and we've got a site that is stopped. If you go and have a look, and I underlined this one part for you from Colto, it says the resubmission of concrete lots on the basis of cause for full acceptance or even conditional acceptance shall not be allowed. So we cannot drill cores. I cannot go and investigate the slab by drilling a core. The only thing I've got is cube results. But the cube results are flawed. Luckily, the next paragraph says the engineer may, at the discretion, decide to use the contractor's test results in the judgment plan if he is satisfied that the contractor has complied with all the process control requirements. Luckily, the ready-mix supplier sampled test tubes for every load that went out to the site. These test tubes was tested in a SANAS accredited laboratory, and the tubes passed. So we could go and sit down with Sandral and the engineers, and we can go there with evidence and a possible solution to the problem. Before we get to that solution, let's just see what Carlton also says at conditional acceptance. For us to get the cubes failed, so we can't get full acceptance. For us to get conditional acceptance, it says the engineer may accept the lot conditionally. That is, the lot may be accepted at a reduced payment in lieu of complete rejection. So we can accept it, but there will be a reduced payment. So the contractor and the ready-mix supplier is now getting less money for the same concrete that was nothing wrong with, but because the cubes failed, they have to accept a reduced payment. And that's unfair. It says provided that the engineer and not will be the acceptance will be at the sole discretion of the engineer. The contractor may have the option to remove and reinstate this concrete for full acceptance, but that will be at a massive cost. And it is also said that the conditional acceptance and the corresponding reduced payment shall apply only in respect of the work and the properties listed in subclause 8208B below. And it gives you a table that says for concrete, the strength and the payment will be judged based on the 28-day cube compressive strength and nothing else. So even if we can pass this, we're now going to get a reduced payment because the cubes failed, but then the lab tested it incorrectly. So what we did is we went down and we sat down with Sandral, the design engineers, the site engineer, the contractor, the main contractor, the ready-mix company, and we put all the evidence on the table. We showed them all the results from the lab that cannot be accepted because it was incorrect, so that is all rejected. The only results we've got on the table is cube results from a SANAS accredited laboratory, but it wasn't sampled on site. In this unique situation, Sandral allowed us to do core testing on the pavement, but because they were uncertain about how the concrete would perform, yes, we did pick up some design flaws in the pavement as well. The acceptance was, for full acceptance, was set at 50 MPa and not 40 MPa anymore. Conditional acceptance would be at 40 MPa, but at a reduced payment based on the cube results that the site lab tested. But if we wanted full acceptance, the cores had to pass a 50 MPa specification. So the challenge was accepted. We drilled 114 cores, 38 sets of cores of 3, one set for every single day of concrete being cast on site. And we tested it in a SANAS accredited laboratory. And what happened is one of those sets failed to meet the 50 MPa specification. In fact, it failed to meet a 40 MPa specification. It was a small section right in the beginning of the pavement of 18 cubic meters that was demolished and reconstructed. And then 37 sets, all of the other ones, passed a 50 MPa spec. We had concrete on site that passed a 50 MPa specification, but the site lab failed to actually even get 40 MPa. So what happened? The pavement was accepted. Great stuff. Full payment for the pavement. But the investigation took us 4 months to get this approved, to go through all the hoops, to get everything retested, redesigned, cored, tested again, reports being written, and the project was delayed, and there was a 1.8 million rand claim or penalty to be paid for late finishing of the project. And at the end of the day, the ready-mix client, my client, settled for half of it, not because he was guilty, but because he wanted to keep the client, because it was a big contractor that he wanted to work with again, and he settled for half of that. There's a lot more that we can look into with this project, and there's a hell of a lot more things that went on. But this was just the core points. And even though everything passed at the end, there was still a massive claim and a massive loss for the ready-mix company because of incorrect testing on site. So in conclusion, to finish off, be careful as a ready-mix supplier when supplying concrete under the Colto or even the new Cotto specifications. Make sure that you design your mixes properly and make sure that you test properly as well. Ensure that the testing laboratory, whether it is employed by Sandral or the contractor, make sure that they do back-to-back testing with a trusted SANAS accredited laboratory so that you have got a comparison with the site lab to see that the guys are testing correctly. And if it's at all possible, don't use the site lab, but use a permanent facility that is SANAS accredited to give you a lot better credible results. Take your own samples as a backup. Even if you don't want to test them, sample them, put them in the water, because something is going to go wrong at some point, and that cubes can save you a hell of a lot of money. And then at the end, you can go to our website, go and download the exclusion clauses. I hear that it's also available, or as Nico said, that it's available on their website as well. But you can go to our Go Consult website, download the exclusion clauses for Colto. We are also in the process of going through the new Cotto spec from back to back, and we're also putting together an exclusion clauses for the Cotto spec, and that will be published on our website probably within the next week. So go and download it, read through it, and whenever you are going to supply concrete for a job or even tender for a job, make sure to include the exclusion clauses to keep yourself safe and save yourself a hell of a lot of money at the end of a project. Thank you, guys. That's my time.
Thanks, Jaco. I've got stuff all over me now. Thanks, that was excellent. I see Moses has got a question. How did the failed core test results, 1 of 38, compare with the corresponding cube test results? I don't know if you quickly want to answer that.
Yeah, I can. So, well, with the cube results that we got from the SANAS accredited laboratory that the ready-mix supplier took, it was just slightly above, but taking into account that the concrete was scored on site only at about 50 to 60 days, and the 28-day results came in about 47, 48 MPa, and an equivalent strength in the cores was about 52 to 54. So yes, there was still a little bit of growth after 28 days as well.
Thanks, Jaco. Kelly, do you have any other questions? Is there other questions that I might have missed?
Hi, Nico. Not at this point. I do assume questions will start running in soon.
Okay.
For now, let's start with our next presenter. Jaco, we will bring you on at a later stage should questions come into the Q&A box.
Perfect. Thank you.
Thanks, Kelly. Thanks. Our next speaker is Barry Pearce. He's the founder of Learning Materials. And I always give credit. It's like Jaco too, when we had to choose people. Barry Pearce, if you've got a problem with concrete and laboratories, there's only one guy you send, and that's Barry. I've got high regard for him. And therefore we asked Barry to come and do a presentation. And he's quite straight. He doesn't mince his words. And I think at the end of the day, we will all have learned something. Barry, up to you, and I'm going to mute myself. Thank you very much.
Right, good afternoon, everybody. I've got a presentation. I must admit, I could possibly speak literally just on the presentation that Jaco has done at this particular point, on some of those aspects as well. But let me go through it in a slightly different approach, and that is how to look at mitigating your material failures, and the associated costs. I mean, I think Jaco has very clearly laid out just one example of what sort of cost is involved when material goes wrong. And although it's a concrete discussion as such, the same is applicable for asphalt or granular material or anything that is processed on site that comes from a primary or secondary supplier. So let's have a look at this particular concept and what we're going to look at today. Presentation will cover aspects of in-house testing. And as you could see from Jaco's presentation as well, the one thing that actually saved those folk was the fact that the person supplying the concrete had already done their own testing, they'd taken their own samples, and material was then approved based on that particular scenario. So I think in-house testing is critically important. Checks and balances on other parties that are involved in approving the material once it arrives on site. It's an issue that lies around the exclusion clauses, particularly when the contractor takes material in a initial form and then manipulates it in some or other way by the adding of cement for stabilized layers, has to compact it. That is not the supplier's issue. That's the contractor's issue. And making a distinction between when is it the contractor's fault and when is it the supplier's fault is something that I think our contracts don't actually take cognizance of. We'll also have a look at an overview of a basic yet effective in-house quality management system that I believe any supplier should have in place. And then the approval of the external testing facilities as well. There is this drive in South Africa for the SANAS accredited laboratories, and I believe it's a good drive. I'm involved in some work with the National Laboratory Association and the civils laboratories, and we've actually done an evaluation on the proficiency testing schemes that we run on an annual basis, of which GoConsult provides the concrete cores, and we've actually shown that the accredited facilities on aggregates actually provide better and more consistent results than what you would get from the non-accredited facility. So it does prove that there is value in having SANAS accreditation. I also want to talk, and Jaco's presentation also pointed certain of these aspects out, but I'd like to expand on some of those with regards to what is this relationship between the client and the engineer and the main contractor, the SANAS accredited and non-accredited laboratories, and also all the suppliers, whether they are a primary supplier, whether they're a secondary supplier. This is actually one of the concrete dams that was produced up in the top of Limpopo. Now, if you're looking at this type of volume of concrete, and they're producing and laying over 1 million cubes per month in that type of work, and you've got to stop the contract, and there's a query over one of the lifts of that particular concrete layer, believe me, it very, very quickly becomes a hugely expensive exercise. And the moment you throw money on the table, the moment you start affecting a person's income in any manner or means, people get really excited. Having a look at the in-house testing. Now, when I'm talking about in-house testing, I'm talking about the concrete suppliers, that's the old SARMA members. I'm talking about the quarries that provide basic materials for the concrete in the form of the concrete aggregates. The same thing would happen with your asphalt suppliers, with the concrete, with the asphalt stone, as well as the binder that goes in there. And all of these aspects have got to be checked. If you, as a supplier of material, don't have, and it's no pun intended, but if you don't have concrete proof of what you have supplied out of your facility with some form of backup to a SANAS accredited facility, you've got nothing to defend yourself against. So for me, the very first thing that you need to have on your facility is a testing system that will give you the ability, what I refer to as, to be able to go to sleep at night. You've got to be able to defend yourself with physical proof, lab results, things that are written down in black ink so that it can't be tampered with. The number one thing that you need to know is, what have you produced? Because if you don't know what you've produced, You can't go into a dispute scenario and say, oh, but we've been producing this for the last 30 years and we've never had a problem before. Firstly, I'm pretty sure they'll be able to find that you have had a problem. But secondly, your word doesn't carry weight in a court of law. Have proof on a daily basis that can be verified. And there are a couple of things that you need to have a look at from a verification perspective, which I'll get into a little bit later under the quality management system. But what do you need to have a look at? You've got to have a look from a production perspective, your dry grading on your basic materials. Once you've got your dry grading result, you've got an idea of what you've got. It's a relatively quick test, and you can do a number of them during the day. Get that stuff out to your production guys and make sure that you make the alterations that are required from time to time as they're required. Your grading, if you're going to be comparing a grading to a SANAS accredited facility, it will have to be the washed grading, and that takes you at least a day to complete because of the drying process after you've washed that material to ensure that you're getting an accurate representation of the fine material. You can't compare a dry grading to a wet grading. So if that's what you're trying to do, you're actually starting off on the wrong foot immediately. The other thing, one of the basic tests that you've got to have a look at is flakiness. Flakiness will be applicable on your granular materials for your crushed base courses and some of the more higher quality sub-bases. But you've also got to have a look at that flakiness for your concrete stone and also for your asphalt stone. So make sure that you run those basic tests. There are basically two tests that you look at: flakiness and wash grading. You can do the dry grading for process control, but then get a sense of what is my dry grading result look like in comparison to my wash grading, because that in itself allows you to start making decisions on whether you're going to be in or out with regards to the product that you're actually producing. These are the most basic tests that are required. You can do more complex tests if you'd like to. Some of them that are maybe not as complex as the CBRs and the MDDs and the mods and so on, but tests that you can actually undertake without having to outlay a huge amount of money, but gives you ammunition that you can defend yourself from in the case when somebody runs a query against your particular result. It might seem like a really odd statement, but it's vital and critical to take this forward with confidence. If you're not able to provide that proof, you're going to battle to actually defend yourself. Basic test facilities are required on premises testing and providing feedback to production as to the acceptance of the various products that are produced on a daily basis. It doesn't help in a quarry type environment taking a test result or taking a sample, sending it to a SANAS accredited laboratory, and in a period of 3 or 4 or 5 or maybe even 7 days, if the facility is really busy, giving you the test result back. Because what has happened in those 7 days during your production, if the test result comes back and says, but your material is too coarse or it's too fine, all that stuff that you've produced over that period of time is effectively out of spec. What are you going to do with it? You spent the money producing it at a certain level. You've got to sell it at a lower level. You're going to be making less money. It doesn't make logical sense. Your in-house testing, commercial versus in-house. It can't be a sample, as I said, sent to a commercial facility because it's going to take a while before you to come back and get a result on that. So you need to actually have a sense of what's going on day for day within your facility. Dry grading will give you that indication if you can compare where you lie with regards to your dry gradings and in relation to what you know you get at with your wash gradings. In fact, if you're doing that in-house yourself, by the following day you would have a clear indication of how your dry grading compared to the wash grading and whether you're still within the spec, because remember, the spec is not based on a dry grading for production. It's based on the washed grading. Should this result reflect a failure, what then? All that material that's out of spec, as I said, you can sell it at a lower price, but it doesn't make sense putting all that effort in to produce good quality material, and then you've got to sell it at a lower price because it's not actually hitting the spec that you require. What is the value of having a laboratory on your facility? You must not undervalue the benefits of such a facility. Yeah, you're going to spend a bit of money on it, depending on how detailed you want to do that particular testing and the extent of the testing you want to do. It's going to cost you slightly more, but the basic test methods of grading and flakiness are not going to set you back millions of rands. The question that you need to ask is this: so what is the cost to your organization annually on rejected and out of spec material, and all the related costs for the dispute resolution, the material replacement costs, litigation should it go that far? If you look at the case that Jaco presented on, 1.8 million, 900,000 rand, basically $1 million, was spent by a client that produced good quality material and was only saved by the fact that they had a plan in place to do it. Why did they pay that extra money? Because they wanted to ensure they got another contract from that guy. That's unfair. It's not just. It should not be happening. I'm pretty certain that if you take the cost of what your failures are per year and you work out what the running cost is to establish a basic laboratory within your facility, whether you are a primary ASPASA type member or whether you're a concrete type organization producing ready mix concrete, the cost of the failures that you can prevent from being an expense to you will way cover the expense of setting up a laboratory. It's going to be considerably lower than what you're going to be expending on those types of things. In fact, if you actually make one saving of a material that is effectively rejected, it will cover the cost of your laboratory plus a lot more within a year. And it's possible even to save money. You can make more than you spent on the testing facility. People will end up with a greater profit. And on top of that, the drive that we've got through ASPASA is to try and improve the image of the ASPASA members in ensuring that they have got a better understanding of what it is they're actually producing, so that when they send a product out, they're not sending out something that they know is going to fail. They're sending out something that they're confident is actually going to conform to the specification. There's a drive that we've done as well within ASPASA. Unfortunately, COVID sort of shot that thing a little bit in the foot at the beginning of this year because it was just about to roll out. And those are technical audits. Audits that have been put in place that are based on SANAS accreditation's process of 17025. And there are basic things that we want to have a look at. We don't expect the laboratories that are doing gradings of flakiness to go the full hog of getting accredited through 17025, but there's certain things that you need to have a look at doing to make sure that you are comfortable that the result that you are producing for yourself is actually making sense. What is 17025? It's basically 9001 for laboratories. It's got a whole lot of technical aspects and not just a paper trail from a management perspective that 9001 has. First thing you need to have a look at, make sure that the personnel that you are using are adequately trained and competent to do the testing that is being produced in your particular laboratory. Make sure that your equipment that you're using is calibrated, and that calibration certificate needs to be done by a facility that is accredited through SANAS. So it's also a 17025 calibrated certificate that shows traceability back to a national and international standard. So there's no dispute over whether that apparatus is measuring correctly or not. The third thing that I think is absolutely important, and it's done to ensure that should you be doing something incorrect within your test method, you will run test after test after test, and you're going to get similar result after similar result after similar result. As Jaco said, these guys were testing incorrectly every single time with a slightly tilted top platen and providing that eccentric load on the other side. Their results were coming out consistently, so they'll look at themselves and say, but hold on a minute, guys, there's nothing to be doing wrong. Our test results are consistent. The problem is they're consistently wrong, and you should be able to pick up on that. besides the fact that the engineer should have seen that as well, but we'll get to that point a little bit later. So you need to conduct tests with an outside facility that will be able to highlight for you where you are testing something where you've got what is referred to as a built-in error. If you've got a built-in error and you compare against yourself, you won't see it. If you're comparing with another couple of facilities, they might be able to point out to you, hey, listen guys, but you got something wrong. We're getting 5 MPa higher than you on a regular basis. Why are you getting it low? And you can then go in and have a look at it, find the fault, and do the correction. So interlab or intralab is a comparison in the form of either ILC, interlab comparison, or PTS, which is a more formalized proficiency testing scheme, with at least one or preferably more accredited facilities, because the problem is if you've got two sets of results and the one is up here and the other one is down there, well, which one is right? You actually don't know. And the average certainly can't be the right answer because neither of you got it. So 3 or 4 or 5, preferably even as much as 6 or more. The national proficiency testing scheme that we do, we run with up to 85 participants. You get a very clear picture of all the results that tend to sort of concentrate around the center, and then you get all the worrying folk that sit on the outside that you've got to then take care of. What it does is it positions you to evaluate your results with facilities that are already approving your material for payment. So if you are testing, even if you're not 17025 accredited through SANAS, and you are testing your test results against those accredited facilities, already you are more confident in your test result because you know that yours is comparing nicely with systems that are already accredited. There is an email that's out for the ASPASA members, for those folk who are actually participating in this presentation or listening in. Please fill it in and return it to ASPASA. It talks around what have you got testing-wise within your facility, and you fill that in. We can start looking at that and then providing information as to how you can go around actually improving your facility so as to save you money. Yes, it's going to cost you a couple of bucks, but by the same token, I think it's quite clear that you can save money a lot quicker with a laboratory than what you can lose money by actually having rejected material. Approval of external testing facilities. If you're going to use an external facility to provide you with critical information as to the quality of the material that you're producing against the specification, check your lab results against their results. Build confidence in their ability to provide you with an acceptable result. Then once you're confident in the results you're providing, you can cut down on that external usage where you're going to be paying for that service because you're confident in your results, and you just keep checking with them every so often at an acceptable risk level so that you know I'm still happy that what I'm testing here gives me good results with an accredited facility. It also builds up a level of trust with regards to their results and improves the confidence you've got in what you're actually producing. Make sure that you're using the same method. As I said, there's a dry grading method and a wash grading method. Don't try and compare those results with one another because they're going to give you vastly different results that are not comparable. And make sure that you're also conducting it in the same manner. So you're using the same method, you're using similar equipment, and you're using equipment that is calibrated, and that you're using staff that is properly trained to actually do that testing. It can't be another branch from the same company, because if the same training program is in place, what the one person gets trained in incorrectly, the other person will have that same error. And you need to be able to find out those errors, okay? So as I mentioned in the previous slide, unless you are able to determine what those built-in errors are, you're not going to see it. The other way of doing that is to bring in an external consultant to actually audit your facility so that they can look at it with a fresh pair of eyes. You will often overlook things because of the fact that you do this on a regular basis, but we've always done this, so it can't be wrong. Well, unfortunately, it can be wrong. And when somebody comes in and looks at it fresh and hasn't looked at the process on a daily basis, they are able to pick out if they're knowledgeable in what needs to be done. They will point out things to you that you can take into account and start applying so that you can actually improve that. And this is the purpose that we're looking at to get this external auditing done within the facilities. Even if you've got a quality management system in place, because you're on the coalface doing that testing every single day, you can actually miss stuff. So that external 10 or 15,000 bucks that you spend on an audit in the year is irrelevant. The cost of one truck going out the yard is maybe more expensive than that if it's a highly modified or specialized material. So that cost easily covers itself in adding to ensuring that your material is not rejected at a later stage. Let's have a look at some of the links with the other parties. Now, I'm heavily involved in laboratories and the setting up of the SANS 3001 test methods. I'm equally very passionate about ensuring that at the end of the day, labs are able to produce results that are not disputed. If you think about it, an engineer is nothing without a test result, because the engineer makes decisions based on whether it conforms to the spec, and conforming to the spec is based on a test result. Okay, so just remember that link because it's vitally important. So who are these other guys? There's the client. That's the oak with the money. There's the consulting engineer, they're the main contractors, there's SANAS and non-accredited commercial facilities, laboratories, and then the primary and secondary suppliers, which a lot of the time would be from the concrete audience we're sitting with, yes, the old SARMA members, and then obviously the suppliers of that, which are closely linked to in ASPASA side of things. At the start of a contract, I believe it is absolutely critical for all of these parties to agree on how will we sample, who will sample, and how often, the frequency of that testing. What will be done before there's a failure? Discuss at the beginning of the contract. It sounds a bit negative, but agree before there's an issue on money. How are we going to do this when there's a failure? Who's the alternative laboratory or laboratories we will use if there's a failure? So all of that is in place. When there is a failure, when there is a dispute, that information is automatically in place. You don't have to sit around the table when everybody's tense and aggro around the fact that now we're losing money. Now you've got to make a decision. Now nobody wants to believe anybody. Okay, set that up before you start your scenario. Just a diagram that illustrates the parties involved. There's the client, and that's the money guy. Okay. There is a direct contract between them and the consulting engineer, sometimes the architect if it happens to be a structure, and the architect sits above that of the engineer. I won't go into why and whether it's a good idea or not. We'll just leave that there. And then there's the agreement between the client and the main contractor. And there's a link between the consulting engineers and the main contractors because they're basically the client's eyes and ears and knowledgeable, I do that in inverted commas, with regards to what the client actually wants and the construction processes and practices. The next folk that sit in on that particular scenario are the people that have provided prices to the main contractors in the form of secondary suppliers, contractors and concrete and asphalt, and then your asphalt ASPASA members as the primary suppliers for that base material, and then also coming in here to the main contractors. There is no link to the consulting engineers and the client in these regard, and they often don't want to get involved in any issues around who that supplier is. They will want to talk to the guy they've got a contract with, and that is the main contractor, and that's problematic. The other group in this environment are the laboratories, whether they're accredited or non-accredited, and there are a couple of links here. The consulting engineer will have a lab on site, and as Jaco said, they are currently not accredited through SANAS, although their head office would be. The new drive is that any contract under SANRAL, which is going to extend for longer than a period of 2 years, those site laboratories are going to have to go through the 17025 accreditation process, which I believe is a good thing. The problem will still lie, of course, with those contracts, the maintenance contracts that are shorter than 2 years, because it just becomes physically impossible logistically to get them accredited. So there is a little bit of light at the end of the tunnel around labs on site, which are big contracts, which are going to have to become accredited. And I think that's going to sort out a couple of the issues. There is also a link between the main contractor and the laboratory. The main contractor might even have their own laboratory. And whether that's accredited or not, obviously starts becoming a little bit more muddy in the water. And then in some cases, even the client will have a laboratory or have a fair understanding of what's required within a laboratory because of who they happen to be. That would typically be one of your clients, which would be your larger clients, provincial administrations, and of course, SANRAL, the National Laboratory Association. So the fact that there's no link between your client here for that their base material and in some cases with regards to that particular laboratory becomes problematic. Let's have a look at some of these other scenarios that we're dealing with a client. It's going to sound a little bit harsh, but I think I'd rather go a little bit overboard with my criticism to make the people sit up and actually realize where the issues actually lie. Basically, the client just wants the final product. They've got a spec, they've got a tendered rate, and they're saying, that's what I want. I'm not interested in how it gets there or whatever. I want the final road built in a particular manner or bridge or structure. The problem is South Africa allows a tenderer to come in and accepts that tender on the lowest price. And I believe that is fatally flawed because everybody's fighting for that lowest place because they know if they hit that lowest place, they can actually get that tender. It's possibly even worse at the moment because everybody's now scrambling for work post-COVID. Some of the clients are knowledgeable about testing, but unfortunately, I think the majority of them are not. And that is a major issue. On the engineering side of things, unfortunately, the engineers are not as knowledgeable about what goes on in a laboratory as what would be liked, or as far as I'm concerned, what is required. If an engineer is making a decision on a test result, if I take Jaco's case and I look at the way those cubes were breaking, the engineer should have seen the cubes were breaking wrong. And he should have actually stepped in immediately and made the correction, besides the fact that I believe the lab should have picked that up as well. So I put the blame on two people's shoulders, the engineer for one, and secondly on the lab side. Basically, the engineer relies on the lab to produce a correct result to make their decisions. So they use it for design criteria. And in that case, Jaco's example there, payment, partial payment, non-payment. Take it out and replace it. And the cost to the party for the wrong decision being made is absolutely astronomical. And in a lot of the cases, unfair. And that needs to be addressed. The ability to analyze the results and make sense of what could have gone wrong in sampling and or testing is often unfortunately lacking. So there's an issue with the engineers because they do not make the right decisions because they don't understand what's happening in a laboratory. Too much reliance on the laboratories is made with too little value placed in the function of the laboratory, where they're often undertrained, underpaid, and undervalued. The engineer should be putting a lot of emphasis on the laboratory because they are the guys that actually give him the information on which he makes his decision. And if he makes a bad decision because he got a bad result and he can't analyze it, he sits there with egg on his face. The other guys, the main contractors, they are quality driven. No, sorry. They're in the business of making money. Quality, unfortunately, is often second place. If it just passes, they're happy. Pay me the money and I'm out of your hair. Testing and sampling experience in most cases is limited. The representativity of the samples that are picked up on site. I normally say, do not pick up your own samples, leave it to the laboratories. They should have a far better idea of getting a representative sample back into the laboratory for testing. At the end of the day, what does the contractor want? The contractor wants the result that passes. End of story. The result passes, he gets paid, everyone's happy. The driver is profit, not quality, unfortunately. From the commercial facilities, that's both accredited and non-accredited facilities. As Jaco mentioned, currently none of the laboratories, and that's possibly something that's misunderstood, none of the site laboratories are accredited unless all the testing is going back to a head office facility. I don't believe the laboratories currently are seen and valued for the critical function they perform. They tell the engineer, basically, yes or no. The staff qualifications are possibly a little bit on the low side, and that's something we are looking at. They are underfunded. They are underpaid. I don't believe they're being properly enough funded to produce a result that is actually reasonable. Basically, the lab is the main quality checker on site. They are actually the facility that gives payment or rejects payment based on the results that they produce. Your lab facility has to be quality produced, quality driven. It cannot be production driven. You can't run a test quicker than a particular procedure. There's a limited minimum time that you can do. You can't do a test method quicker. If you've got less staff members in the lab than what you actually need because you're trying to save money, you are going to make mistakes in that laboratory. Other parties involved. So around the laboratory side of things, are there issues in the testing facilities? Absolutely. Are we better off than we were 10 years ago? I believe we actually are. Is there still work to be done? Absolutely. And this is all hinged around the laboratory side of things. What I need to ensure is that everybody has their eyes on the labs, keeps them in line, so that everybody can save money on the unnecessary material claims and disputes that actually occur. On the SANAS website, for those SANAS accredited laboratories, there's a complaints tab. You can actually click on it. I've had a discussion with SANAS recently, and they're actually going to put a little notification up there to say, listen, if you do put a complaint up there, it's actually going to be treated as anonymous, and therefore there's no dispute or come back to your particular facility. And the idea would be with those types of complaints, we want to pick up the trends. What are the main issues that are being dealt with? Because if a certain trend is being picked up on a regular basis, we can then actually look at addressing that issue through SANAS and through the NLA and other organizations like ASPASA. The other thing is SANAS needs to get to the point where they've actually got a couple of teeth in their mouth, that if there is an issue with a particular facility, they need to start suspending those facilities, or at least, at the very least, suspend that particular test method out of their schedule of accreditation. So in summary, where do the problem lies? I believe the problem lies in some cases with the client, and Sanral might not be too happy with me saying that, but there are issues with some of the aspects of how the clients do not get involved in a quality assurance process where they check the material as it arrives on site to approve it, so that some of the exclusion clauses that are actually around at the moment can be done away with, because I believe they cause unnecessary tension because that approval system is not in place. There are issues with the engineers because they don't understand enough about what happens in the laboratory. There are issues with the contractors because they also don't understand enough about what happens in the laboratory, and all they want is a result that passes. The suppliers are maybe not checking their material on a regular enough basis and cross-checking their material with some form of quality management system and ILC or PT scheme with other facilities that are SANAS accredited, so as to provide themselves with proof. And then, of course, there are the laboratories, and I think we're all aware of where the problems lie in the laboratories, and there's a big drive to sort that out. Everybody needs to work together, not point fingers in the other direction around what is right and what's wrong. When there's an issue, you all sit down, everybody's involved, sort out the issue. Who needs to pick up the tab, picks up the tab. That's unfortunate, and then we move forward. But don't do it again. That, for me, is criminal. Of course, the other part involved is the primary and secondary suppliers. And in that regard, you need to know your product's test results. That knowledge is your best line of defense, and it can save you an absolute fortune. That's me done. Company I work with, Learning Matters. Learning does matter. It is vitally important. And there's my cell number and email address. So if you do wish to get hold of me, either through directly myself or through Nico, that's me. Nico, thanks very much indeed.
Thanks, Barry. That's as I normally know you, very direct and very good. And yes, excellent. You and Jaco did exceptionally well. I see there's one or two questions. I don't know if Jaco, have you checked what they've asked you? Do you want to sort of jump in and quickly answer that? And then Barry, maybe there's one or two for you. And then we've got another few minutes, and then we're going to have to close down. Jaco, up to you, bro.
Yes, thanks, Nico. I see that I did answer some of the questions that was asked on the chat, but there was one question about a section of the N2 in Cape Town that was laid in concrete and was later lifted due to failure. The question is, could this have been because of an incorrect concrete strength? Now, there's a lot of reasons why this concrete could have been lifted and taken out. There was a section of road, and I'm not quite certain if it's the same one that was in Durban as well. It was one of the first ultra-thin concrete linings that they did, and that was later lifted. There was 2 issues with it. There was some delamination that took place and curling, even though there was some steel, and then there was also some abrasion on the surface. So the cement paste was a little bit on the weaker side for the heavy traffic that it had, and it started to abrade, where it doesn't really necessarily make potholes, but the stones start to appear. And if the stones are not correctly chosen, that could start to damage tires and so on as well. But being in Durban, a concrete pavement or a road of a highway section will always be heavily reinforced. So it is likely that the strength was good, but the durability of the concrete wasn't all that good, and there was some corrosion that could have started taking place with chlorides penetrating into the concrete. It's close to the coast, so there's multiple reasons why it could have happened, not necessarily just a failure of strength of the concrete.
I can maybe just add in there, Jaco, that section that you noted about that it failed was actually on the exit from the Toyskloof Tunnel. That's on the N1 heading north. That's where that curling and the abrasion took place. It's different to what happened on the N2. It depends on which year they were referring to on when that concrete was removed from the N2, but I don't have knowledge about what actually happened on that N2 one myself either, even though I am Cape Town based.
Right, thanks, Jaco. Danny, have you got a question for yourself there on the list which you want to answer?
I haven't seen in a few words. Would you guys explain the exact problem with the N2 highway closed last year?
I see your presentation was well received. Thanks, Barry. Jaco, yours too. Maybe we should allow, if there's anybody who really wants to ask a question. Kelly?
Nico, I see there's a question about the M2 bridge in Johannesburg and why it was closed down and the revamping of it. We actually, the Concrete Society, actually the site visit to the bridge to have a look at the repairs. If I remember correctly, the reason was that some of the concrete at the bottom of the bridge delaminated and fell off the bridge. And luckily nobody got hurt or anything happened. It was during the night that it happened. But in this case, this is a classic case of some of the older concrete bridges that was built when durability of concrete wasn't that massive of a focus point in concrete at the moment, as it is at the moment. But what happened is the steel reinforcing started to corrode inside the bridge, not due to a lack of cover, but due to carbonation taking place in the concrete. Now, under a bridge, CO2 emissions from cars are quite extensive. So the concrete started to carbonate. That destroys the passive layer that protects the reinforcing steel. And once the carbonation depth reaches the reinforcing steel, it basically starts to corrode and it expands. And when it expands, the concrete starts to crack. And you'll get that sections will delaminate away from the reinforcing steel. So they removed all the covercrete. They treated the reinforcing steel, galvanized it again, and then replaced a cover layer on the steel. Bridge structurally was 100% sound. It was just the outer layer of the concrete that started to come loose that they then repaired.
Thanks, Jaco. I must just say, it's most probably the first time, and I've been around for quite a while, that we've had such a in-depth look at the problem, because I think it's normally an issue that's not addressed. And you know, you have these individual cases which you, Jaco, and which Barry gets involved in, and I get my ear bent by people. But I think it's crucial, and I'm so glad that DMG events raise this thing, and maybe we should have a follow-up and carry on in the future about these shortcomings, because I think in South Africa we haven't seen the American system where people get sued. So there, if you've got a PR inch behind your name, it doesn't help. You go to court, you get sued, and you get fined. If you're a supplier and you don't do it properly and you can't prove your case, you get sued. So I think it's becoming quite a legal issue, this whole thing about quality, about tests, people making decisions on wrong tests. I mean, what we saw there from Jaco, I mean, it's quite shocking to see that they continuously do the tests wrong. So I'm so thankful for the presentations, thankful for all the people that participated, because I see there's a huge amount of people that participated, and thanks for that. DMG is going to have this video, and you can contact them. And again, I think we're running out of time. I've been told to keep to the time. If there's a last thing you want to say, Barry or Jaco, then please feel free to do so, and then we're going to close down.
Yeah, Nico, just in response to two of the questions there, one from Bruce Roth and one from Hussein. My feeling on accreditation, I believe it's actually benefited the laboratories, and I think the push or the drive by SANRAL to move their 2-year and longer contracts to accreditation is going to be of benefit. So that is my take on it. The other thing is the question from Hussein with regards to there are certificates that are produced by the steel producers that are then given to the engineers. My feeling would be it's exactly the same as getting a result. There's bias in that. You, as a provider of steel, I'm not going to give you a certificate and so that it's failed. Of course, I'm going to tell you that it's passed. So I would do spot checks with an accredited provider of steel testing just to make sure and satisfy myself that that test result actually is valid. Check it for a number of times. If you're happy with that, you can actually expand that period of time. But don't just take it on a certificate from a supplier. There's way too much bias involved in that scenario.
Jaco, something lastly from you?
No, from my side, just the same answer to Bruce. Bruce's question about the accreditation. I think that's a debate that we can have another session about. I've got a SANAS accredited laboratory myself, so for that reason, I do think that it's important. But I have also been part of the NLA testing, where there's a hell of a lot of the accredited laboratories involved with. And even though most of the testing is done anonymously and we don't know exactly who the labs are, I can tell you there's a lot of SANAS accredited laboratories that does not test up to standard. They test well every 18 months when the accreditation comes up for renewal, and everybody's books are up to standard and all the paperwork is right and the testing looks all well, but it's not all that well behind the scenes. It's a way to make money. It's guaranteed. We've got a business. We have to make money. SANAS accreditation has helped us quite a bit to get certain projects through. But it will be from every person. I'm always of the opinion, if it's worth testing, it's worth testing it correctly. Because it takes just as much effort to do it incorrectly than actually doing it correctly as well. I believe it's good, but always make sure that you've got more than one set of results and double check everybody. That's it.
Thank you, Jaco. Yes.
Can I just make a quick response there? You know, this whole SANAS thing is also a hotly debated point, and to a certain degree, I do actually concur with what Jaco said. The fact that there are SANAS accredited laboratories that do not provide accurate results or correct results at certain instances. Yes, there's a lot more attention given when they're physically audited, but the fact of the matter is that tab on the SANAS website, which allows people to raise complaints against SANAS accredited laboratories, unless we get that feedback from the industry when there's an issue with an accredited facility, there are no issues. There's no proof that there is an issue. And the people also, that when a contractor has an issue like this, they don't like to advertise the fact. So people are very cagey around putting this sort of stuff out in the public domain because it points to maybe bad practice, or this contractor doesn't do good work, or that laboratory doesn't test nicely. And my feeling is we should get past that. We've got to use the systems that will keep the people on their toes, because if we don't, we're going to sit there going around the same bush day after day, complaining about the same stuff time after time, and we're not going to sort the problem out. Until we sort the problem out and people take action without the legal side of it involved, don't complain about the fact that it's not working correctly. That system's in place. Use it.
Thanks, Barry. Thanks, Jaco. And I just want to say thanks to you two for doing those excellent presentations. Also want to say thanks to all the people that joined. I see on my screen here, it's roughly in the region of 160 people, which is beautiful. I mean, we wouldn't get them 160 people together in a conference center to come and listen. I mean, we didn't have that in the past. And for DMG events, Kelly and Zara and your colleagues, thanks a lot. You did exceptionally well, and I believe this was a great success. And Kelly, up to you for the final bye-bye.
Nico, thank you so much. I just want to add, I know there are two more questions, or there's three more questions. We are worried about time. I wonder if we shouldn't just give the opportunity to just answer these three questions, Nico, if you're happy with that. If we could answer them within the next 5 minutes, then we're good to go. I don't want to make the three people who answered the questions upset with me. So if we could give them the opportunity to answer these questions, and then we'll wrap up. Before we end, I just want to say that we'd like to thank ASPASA for supporting and accrediting this session. Just again, in the coming weeks, we will email all those in attendance the validation information. You may then use this to claim through the Engineering Council of South Africa for your CPD. Of course, you will need to be registered with the Engineering Council of South Africa. So we'd like to thank, just before I go, our moderator, Nico, and our presenters, Barry and Jaco. So I'll leave it to you to answer those three questions, and then this concludes our 3-day digital talks. Thank you so much from me and DMG.
Thanks, Kelly. Okay, who's going to answer the questions? Have you got them, Jaco and Barry? Quickly, but we have.
I see there's one from Hussein there about cubes testing high, and they've changed labs and it still tests high. Hussein, be thankful that it's not low. There's nothing wrong with concrete testing high. We designed it specifically with a safety factor to be high. Concrete being a couple of MPa higher, even 10 MPa higher or so than the specified strength, it will not have a negative influence on the structure at all. So there's nothing wrong with that. It's supposed to be high. It's supposed to be above the specified strength.
Thanks, Jaco. Barry, have you got one you want to answer quickly?
Yeah, Tabang, are you saying we're entering an uncertain time where engineers or contractors and suppliers don't trust us? I don't think we've ever left that period. I think it's always been like that. I don't think any of the guys trust anybody who's providing anybody with information. All I'm saying is, if you are providing information, if you're providing a product, make sure that you know what you've provided. Be confident in your test results, that when it's compared with another laboratory or another supplier, that they come out with a similar set of results. Without that, we're nowhere. So make sure that you can instill that trust with the engineers and the contractors. Absolutely.
Thanks, Barry. Kelly said there were three. Is there another question?
There's one from Fagika as well that asks, what if it tests high too quickly? So it's not really a problem. It means that we've got high early age strengths. A lot of the rapid hardening cements gives you quite a high early strength. It can be good because we can strike our formwork a little bit quicker. The concrete protects itself a little bit quicker. There's nothing that there will be excessive drying shrinkage because of high early strength or anything that goes wrong. Strength is a good thing. That's what we wanted, and the earlier we get it, the better at the end of the day. And then there was another question that I'm not quite certain if I understand it correctly, how we can recognize default of strength from lack of concrete sample curing, or maybe a lack of concrete sample curing. At the end of the day, curing is quite important. That's a whole session on its own. If we don't cure properly, we're not going to get the strength. I always say, concrete is like a baby, a newborn baby. If you don't feed it, you don't keep it warm, we don't protect it, it's not going to grow up to be a strong, healthy person. So we need to cure it. If we don't cure, yes, there's going to be a lack of strength. Absolutely.
Thank you, Jaco. Thank you, Barry. And Kelly, now we're going to close down. Is that that's correct, huh? Guys, go well.
Thank you so
Go
much.
safe. Go well, go safe. And on Monday, the 21st, we're going to the next level. The president knew my birthday was on Monday, so he's declared Monday a very special day.
Thank you, Nico. An early happy birthday from all of us. There's just one comment from Jonathan. We will send you the validation number, and you'll get everything from us in the coming weeks for you to get your CPD points. So not to worry, we will be in touch. Thank you all very much, and take care. Bye-bye.
Super. Thanks very much, folks.
Thank you,
Cheers.
guys.